In previous lecture, we saw this example. Okay, today we will solve in detail this particular example. Okay, so let's solve it. This is the polygon, okay, the triangle which is in yellow color. We are going to clip the polygon against the window. Window is in a rectangular or in a square form. Okay, so window coordinates are 150 comma 150. I mentioned in black color. Okay, and polygon coordinates, that is the triangle coordinate, I mentioned in a red color. Okay, so these are the coordinate. Let's start clipping the polygon. If you remember, I told you to use the same intersection formulas which we have used for the line clipping. Same way we are going to proceed here as well. Okay, so first you need to clip the left hand side. Okay, so clip left hand side, left side, okay, against the window for the polygon. Fine. So if we are going to clip at the left hand side, here I have highlighted with the green color intersection points. This is the first intersection point, this is the second intersection point. So second intersection point is basically already calculated because it is passing through a window vertex. Okay, so 150 comma 200, no need to calculate, but we need to calculate this particular intersection point. Okay, say the intersection point is I1. Okay, so for this I1, what we are going to do, we'll just write it I1. Fine, I1 like this. This is I2, this is I3, this is I4. Okay, four intersection points are there. So for left clip, let's solve it. First we need to calculate the slope of a line, that is AC. Okay, so slope for line AC, okay, is equal to M is equal to, okay, what is the slope of a line? Y2 minus y1 divided by x2 minus x1. So here x1 y1 is 100 comma 150 I considered, and x2 comma y2 is 300 comma 200. Fine. So 200 minus 150. Okay, 200 minus 150 divided by 300 minus 100. Okay, you will get here 1 divided 4 is the value for the line AC. Fine, we have calculated the slope. Now here in this case, the left hand side point for I1 is XL. Okay, XL is the point which is nothing but XW minimum. Yes, window minimum coordinate. Okay, and what is that? That is nothing but 150, right? So what about YL? YL is not known over here. We are going to calculate the YL point. So just write the formula which we saw in the last lecture as well, previous lecture. Yes, Y1 plus M into XL minus X1, right? This is the formula. Then is equal to Y1 value is 150. Yes, this is the Y1 value over here. Okay, plus slope is 1 divided by 4, 1 divided by 4 in bracket. XL value is nothing but XW minimum, which is 150. Okay, minus X1 is 100. X1 is 100. So after calculating this value, you will get 162.5. Okay, just calculate it, you will get the same value. Fine, 1 divided by 4 into 1 divided by 4 into 50. Okay, that is nothing but 12.5. Add it to 150, you will get 162.5 over here. 162.5 over here. So let's I1, okay, that is equal to that is equal to that is equal to XL comma YL, okay, which is equal to 150 comma 162.5. Okay, so let's write the left hand vertex now. Left vertex list, I will say it, left vertex list after clipping. Okay, after clipping, left vertex list is equal to what all points are there, 150 comma 200. Then next point is 150 comma 162.5. Okay, next point is, okay, left points are completed. Basically keep the remaining points as it is. This is the left clip only because, so keep B point as it is. Okay, and keep C point as well as it is because we are just dealing with the left hand side currently. That's the reason. Okay, left side completed. Then we need to move ahead to the next, that is clip right side. Okay, clip, sorry, we will first deal with the top side. Clip top side. So if you observe, while clipping the top side, B to C, right, we are moving from A to B and B to C, then C to A, like this. Both the points are outside. Do we need to save anything? No, nothing is going to be saved over here. So just I will write the top vertex list directly over here. Top vertex list. So what all points are involved, what all vertices are involved here, 150 comma 200 is there. Okay, 150 comma 200. We'll move in a clockwise direction so that will be better. Okay, then 150 comma okay, 300 comma 200 will be there because we are dealing with the top only. So right side point will be as it is. Right side point will be as it is. Okay, and one more is there, which point, 150 comma 162.5 comma 162.5. This is the top list, we got it right. Now move ahead to the right hand side. So basically now clip right side portion now. Okay, there is nothing at the bottom to clip. If you observe, below the window nothing is there, so no need to clip for bottom side. So clip right side. One I4 here you will get, right, I4 point. So we need to calculate the I4 point. Let's calculate the I4 point. So consider slope of the line, we have already calculated. Same line is there, AC, which is 1 divided by 4. Right, XR is it nothing but XW maximum over here, and which is nothing but 200, right? Then what about YR, which is unknown over here? YR is not known, so let's calculate the YR value here. yr is equal to, same equation we are going to follow, y1 plus m in bracket xr minus x1. Okay, so is equal to y1 is 150 plus 1 divided by 4 in bracket. Okay, xr is 200, x1 is 100 minus 100. Okay, so here you will get 175 after calculating the point. Fine. So which point we got over here? xr yr, that is i4, i4 i4 is equal to xr comma yr, which is equal to, okay, 200 comma 175. I4 also we got over here. Now what is the next step? Write down the vertex list. Okay, write vertex list is equal to, okay, 150 comma 200 is there. Yes, go in a clockwise direction. 150 comma 200 is there. Next, what we got? 200 comma 200 comma 200. Okay, that is I3. Then here is the I4, which is 200 comma 175. Okay, and last is 150 comma 162.5. 50 comma 162.5. Fine. So finally, what is our vertex list? Yes, I will write it here. Vertex list will be I2, okay, comma I3, comma I4, and one more is there, I1. Join all these point. Okay, after joining all these point, how the polygon will look like now? Yes, here we have seen it yesterday as well. So this is the part after left clip. This is after the top clip. Okay, and below is after right edge clipping, and this is the final vertex list. Okay, in this way we have solved the problem. Okay, so I will just give you the final image over here. This is the final image. Fine, here we got it like this. Now we saw the drawback yesterday, okay, in last lecture. So that is nothing but extra age is there, right, in case of Sutherland-Hodgman algorithm. So I told you we are going to deal with the another algorithm, so there won't be any error in the algorithm, or you can say there is no extra age going to come, right? We'll just click it new. Fine. Name of the algorithm is Weiler Atherton polygon clipping. Okay, Weiler, W-E-I, Atherton polygon clipping algorithm. Okay, let's see how it works. It also follows the polygon boundary. Okay, but sometimes it follows the window boundary. So there are two things in case of Weiler-Atherton algorithm, two cases. Okay, sometime you need to select the polygon path, and sometime you need to select the window path. Then when to select what? Okay, at what time you are going to select the polygon path and what time you are going to select the window path. So suppose you are going in a clockwise direction. Okay. Mm, say this is a polygon. Okay, or this is a polygon, whatever it is, fine. And at that time, if you are moving in a clockwise direction like this is the clockwise direction. Okay, so at that time, if you are moving from outside to inside, I will draw a concave polygon better. Okay. Mm, because there is a issue with concave polygon, right? That's the reason. Okay, this is the concave polygon, and now we will select the window. This is our window. Okay, then in this case I will draw the directions as well. Moving in a clockwise direction like this. Okay, A, B, C, D, and E. Okay, I will draw the intersection points as well. This is our window. Again, I will show you what is our window. This is our window. Okay, this is our window. So this particular portion will be inside the window. See, this much portion inside the window only. Okay, remaining is outside the window. Fine. So let's understand it. I will just put the intersection points over here. Okay, quickly. I will put it like this. Say P1 intersection point, P2, P3, and P4. Okay, these are my intersection points. I hope you are imagining the boundary over here. This is my boundary. Okay, so according to that I put the intersection point. From B to C there is a P1 intersection, from C to D P2, D to E P3, and E to A P4. Okay, these are the intersection points basically. Or I will draw the polygon, that will be better. Okay, so yes. Okay, mm, this is my window. Yes, this is the blue is clipping window, and this one is polygon. Okay, A B C D D E is the polygon. Okay, so let's understand it. See, we are moving from B to C. A to B, both the vertex are outside, so we are not going to save anything over here. We are moving from B to C. Which vertex need to save? Yes, what all vertex you need to save here? Intersection point, which is nothing but P1 comma C is saved, right? Now you are moving from inside to outside. At that time we are going to follow the window boundary in a clockwise direction. This is the window boundary. I will highlight the window boundary. Okay, quickly. This is the, sorry, This is the window boundary. Yes, this is the window boundary. Yes. So in a clockwise direction, right? So here from B to C, we have followed the polygon boundary outside to inside. Okay. Save P1 and C intersection points. Okay. Now we are moving from inside to outside. At that time, follow the which boundary? Window boundary. And here we are going to save in this case. Okay, for BC we have saved P1 comma C. In case of CD, in case of CD, we are going to save which points? Yes, we'll rewrite it quickly. Just a minute. For for line for line BC, we saved P1 comma C points. Okay, for line CD, we need to follow window boundary and here save P2 comma P1 in this case. Okay, go ahead. Again, you are here moving from D to E, that is from outside to inside, right? Follow the polygon boundary rule over here for DE. Okay, and what is that? Save intersection point and inside point, that is nothing but E. For line EA or AE. Okay, EA. What we need to do over here, moving from inside to outside. Say EA is we are moving from inside to outside. So what all things you are going to say? In this case, again follow the polygon boundary. Okay, polygon boundary according to clockwise direction. So save P4 comma P3 here. P4 comma P3. Okay, P4 comma P3. Fine. So we have to draw a polygon containing the vertex P1, C, P2, P1, right? Now I will select it so that you will understand after clipping how it will look. How it will look. Okay, this much portion is clipped. Yes, sorry. This much portion is clipped. I will just move it. Okay, just a minute. Yes, okay. Then here against the boundary I will directly clip. Yes, lines are coming basically. I have drawn this window now. Better way I will redraw it. Okay, so P1C, fine. Then C2, C2, P2, right? And P2 to P1, fine. So here it is. I will name it P1, C, P2, P1. Okay, and another half is remaining over here. I will just draw it quickly. P3 to E, then wait, P3 to E, then here it is E to P4, right? This is the polygon boundary. Okay, what time? Sorry. Yes, now it's coming properly. Yes. Okay. So this is the portion clipped. I will highlight it. Okay. With P3, E, P4, E again. Okay. So clipping is happened properly now. Fine. There is no extra edge produced over here. So what you just need to remember over here, if you are moving in a clockwise direction from outside to inside, then follow the polygon boundary. If you are moving from inside to outside, follow the window boundary over here. And that's the only rule in case of Weiler Atherton algorithm. Fine. And that's the end of all algorithms, clipping algorithms we have seen from the second unit. Fine. Windowing and clipping concept is completed over here. Second unit is completed. Thank you.